Okay, so we are now on 7.4. We're going to be adding, subtracting, everyone's favorite. You did this in elementary school, but still seems to give a lot of people a tough time. So let's go through these. So first, remember adding, subtracting. When you add or subtract fractions, you need common denominators. Okay, so when you go back just to elementary school, the least common denominator is between 5 and 8 is 40. So to turn this one into 40, I multiply the top and the bottom by 8. Because when I make this 8 over 8, what I'm really doing is just multiplying this fraction by 1. So I'm not changing what it's worth, I'm just changing the way it looks. And to get this one into 40, I multiply the top and the bottom by 5. Again, I'm just multiplying it by 1, so it has a different appearance, but it's still worth the same as 5/8. So anyway, I get 24 over 40. Here I get 25 over 40. And then once you do that, you actually just only add the numerators. Remember, adding, subtracting is very picky with its rules. And the denominator just comes along. Okay? So then, in our chapter 5, we had something like this. So these are supposed to be exponents. They're a little big, but the idea is when you have the same base, you subtract the exponents. So I need to take 1/4 and subtract 6/7. So the least common denominator between 4 and 7 is 28. So I multiply both of these by 7 and both of these by 4. And I get 7 over 28. And here I get 24 over 28. So when I subtract, I end up getting negative 17 over 28. In the end, just subtract them for 17 over 28. And then your job is just to figure out where should this go, on the top or the bottom. And 6/7 as a fraction is worth more than 1/4. So there are more x's on the bottom, they're on the top. And that's what the negative that would be here would say. Negative goes on the bottom. So when you're done, this one is like this. Again, there are more x's on the bottom, that's where your fraction ends up. So how do you add and subtract rational expressions? So the first thing we're going to do is add the opposite. So in adding the opposite, what I want you to do is to add the opposite between fractions. Okay? The next thing you're going to do is you're going to factor the denominator completely. If the denominator is a single term, factor using factor trees. We'll talk about that in a little bit. Determine the least common denominator. You need to make something that is known as the least common denominator table. And I think this is the first time we're seeing this. I don't think we saw it before when we were multiplying and dividing. I'm making these videos a little backwards. So, nope, we didn't do it there. So I'm going to show you something called the least common denominator table. Anyway, once you do that, you're just going to multiply your fractions, numerator and denominator, by the missing factors needed to create the least common denominator. So basically what we did up here with the 8 and the 5, or the 7 and the 4. And then you just combine your like terms in the numerator, because you add your numerators or subtract them. And we're just going to leave our denominator in factored form. And we're just going to bring it along, just like we brought the 40 along. And then we'll go back to those domain and those excluded values again. That part is not new. So first, I do not need to add the opposite. If you really want to add the opposite here, you can, but what I'm looking for is adding the opposite between two fractions. So first we're going to factor the denominator completely. X plus 3 cannot be factored anymore. 2x plus 1 cannot be factored anymore. So together they make up our least common denominator. Okay? So the least common denominator for this problem is x plus 3 and 2x plus 1. Okay? Just like the least common denominator came from putting 5 and 8 together for 40, we're going to put these two together. So what I'm going to do is, we've done step C. We couldn't do B. We figured out the least common denominator. I'll show you this least common denominator table on the next page a little bit more. So what I need to do is multiply each fraction's numerator and denominator by the factor it needs. So I have the least common denominator. So if the least common denominator is this fraction already has x plus 3. So what it still needs is 2x plus 1. So I'm going to multiply this one by 2x plus 1 on top and 2x plus 1 on the bottom. And then over here, this one already is 2x plus 1, so I'm going to multiply this one by x plus 3 on the top and x plus 3 on the bottom. So that's step D. What we're going to do now is we're going to combine the like terms in the numerator. So basically, what you're going to be doing here is just a lot of multiplying so that you can, or distributing so that you can combine those like terms. So we're just focusing on the numerator. So in this fraction's numerator, I have 2x plus 1 and 2x minus 1. And in this fraction, I have x and x plus 3. And now I'm just going to multiply these. So let's start with the easier one, the x and x plus 3. I'm just going to distribute that through. So I get x squared plus 3x. Here I'm going to distribute. I'm going to get 4x squared. I'm going to get a negative 2x, but as soon as I multiply this, I'm going to get a positive 2x, and those are going to cancel out, so I'm not going to write them down. And then 1 and negative 1 give me a negative 1. So now that I've done all my multiplying, now I'm just going to combine my like terms. 4x squared and x squared is going to be 5x squared. Negative 1 and 3x don't have anything to combine with, so they'll just come along. So that's step E. What we're going to do is we're going to leave the denominator in factored form. We're just going to bring it along. So this common denominator of 2x plus 1 and x plus 3 is just going to come along. And this is our now added fraction. Just like we got 29/40 here. This is our version of 29/40. And then don't forget that domain. What, or those excluded values, what would not work? So that's supposed to be a 3. It doesn't look very good. But I would never pick negative 3 for that fraction. That's going to make my denominator equal 0. And then 2x plus 1, if negative 1/2 would make that 0. So here's my answer, and here's my domain or my excluded values. All right? So let's talk a little bit more about this least common denominator table. So that's what this whole page kind of goes with. All right? So finding the least common denominator. So if I wanted you to find the least common denominator between 8 and 16, basically I want to know what's the first number that 8 and 16 have in common. So if you just started listing multiples of 8, not that you need to do this, and multiples of 16, you're going to actually see that they have a couple of numbers in common, but what we want is the first least common multiple or denominator that they have in common. So for this one, you know, between 8 and 16, this is just going back to middle school, you can see that the least common denominator is 16. So this one would be good to go, and I would have to multiply this one by 2 so that I could get that denominator 16, where this one's already set. Okay? So let's take a look at when we start to put letters in it. So I have 4's, x's, y's, and z's. So if I just kind of start comparing, you know, I don't know, apples to apples, I don't know how to say it, between 4 and 6. The first number that 4 and 6 would have in common is 12. When I look at x squared and x to the 4th, the first number of x's that I could get them both to is x to the 4th. Y to the 5th and y to the 3rd. The first amount of y's they could both have is y to the 5th. And then, let's see, this has a z to the 6th, so I would just need to make sure that the other one has a z to the 6th. So you build them up. We don't build them down. 4 and 6 is built up, the x's are built up, the y's are built up, the z's, well, they stayed the same because they're the only ones. So when I look at this one, and I'm trying to get this least common denominator, my least common denominator is 12, x to the 4th, y to the 5th, and z to the 6th. So for this one, you know, to get from 4 to 12, I'd have to multiply this by 3. 2 x's, and I need 4, so I'd need 2 more x's here. 5 y's, well, I already have 5 y's, so I don't worry about that. And I don't have any z's, so I need to make sure I multiply this by z to the 6th. So when I multiply, 4 and 3 is 12, 12, x to the 4th, y to the 5th, z to the 6th, and I've got my least common denominator. So for the 6, to get from 6 to 12, I'd have to multiply that by 2. I have 4 x's, I'm good to go. 3 y's, I need 5, so I'd have to put 2 more y's with it. And 6 z's, I'm good to go. I have them all. So I'd have to multiply this one by 2y squared, and then I'd have that least common denominator. So what about this? Well, what you want to do is factor it. So I'm going to factor this. Again, we should be good at factoring. I'm not going to spend time factoring these simple ones. I'm going to get x plus 3 and x minus 1. And when I factor this one, I'm going to get x minus 4 and x plus 3. So now I'm going to show you this least common denominator table. What you want to do is look at each thing. So like this would be a denominator of one fraction. This would be a denominator of another fraction. And you're going to make this fraction table. So you've got fraction 1. Imagine that's the denominator. You got fraction 2. That's the denominator. And each unique factor is going to get its own column. So x plus 3 is a factor, x minus 1 is a factor. They started out. They each get their own column. I'm going to keep them in parentheses. So when I go to the second fraction, this is the denominator, is what we're imagining. X minus 4 doesn't fit these, so it starts its own column. Okay? But this x plus 3 I've already seen before. I don't need 2 of them, I just need 1 of them. So if you do this, and then you just bring everything down once, this will be your least common denominator. X plus 3, x minus 1, and x minus 4. So what I would have to do then, and I really should have put this over here because I need this space, is when I look at this fraction denominator, it already has the x plus 3 and the x minus 1, so I'd have to multiply this one with an x minus 4 so that it has all 3. And this one has the x minus 4 and the x plus 3, but what it still needs is the x minus 1, so that's what I'd multiply this one by. So let's take a look at this one. Again, I expect that you can factor this. This becomes x plus 6 and x minus 5, and this is x minus 9 and x minus 5. So again, some of you can look, you can see that least common denominator. If you can't, I'm going to make fraction 1 and fraction 2. And again, fraction 1 just starts at x plus 6 gets a column, x minus 5 gets a column. Then when I go to the second fraction, x minus 9, that's new, that's unique, so it gets its own column. And then the x minus 5 I've already seen, so it's just going to double up in the other column. So when you bring everything down once, you're going to have a factor of x plus 6, x minus 5, and another factor of x minus 9, and these three together make our least common denominator. So if you go to this fraction, it has the x minus 9 and the x minus 5. It still needs the x plus 6, so I would have to multiply with that one. And this one has the x plus 6 and the x minus 5, but it needs the x minus 9, so that's what I would multiply this one by. So with that in mind, let's check out this next problem. So the first thing I'm going to do, going back to my notes from the beginning, you guys would flip over, mine are stapled, is I'm just going to add the opposite. This is happening between the fractions, so I want to, when I add the opposite, have this apply to my numerator. Okay? The next thing I'm going to do is factor the denominator completely, and you might need to make that least common denominator table. So again, I'm hoping that you guys can factor this. This turns into x plus 7 and x minus 4, and this one turns into x plus 3 and x minus 4. So at this point, comparing this one to this one, some of you see that least common denominator. If you don't, that's okay. What I'm going to do is just come over here, make my little fraction table, fraction 1, and fraction 2. And fraction 1 has an x plus 7 and an x minus 4. Okay? And this one has an x plus 3 and an x minus 4. So the x plus 3 is going on its own, so an x plus 3 and an x minus 4. Okay? So from there, if you just bring everything down once, here's your least common denominator, x plus 7, x minus 4, and x plus 3. Okay? So this is your least common denominator. So what I'm going to do is come back over here. I don't need these old denominators. I've got their factored versions. And this has an x plus 7 and x minus 4. What it still needs is an x plus 3. So what I'm going to do is multiply this fraction, top and bottom, just like we did over here, by 8. I'm going to multiply this one by x plus 3. So top and bottom. And I just got the warning about my battery. It's going to die, so I got to quickly plug this in. So hold on. It's going to wobble. I'm going to do this. Okay, so now I'm going to go to this one. This has the x plus 3 and the x minus 4. What it doesn't have is the x plus 7. Okay, so done that. Okay, so we multiply each fraction's numerator and denominator by the missing factors needed to create the least common denominator. We did that, and now we're just going to focus all our work on the numerator. Okay, so in this fraction, my numerator is x plus 3 and 2. They're multiplying, so I'm going to put the 2 first. And in this fraction, here's the plus sign, connecting them, I have a negative x and an x plus 7. So now it's just lots of multiplying. Distribute. Distribute. And now I'm going to combine my like terms. So I'm going to get negative x squared. 2x and negative 7x is going to give me negative 5x. And then the 6 comes along. So I just did step E, just got all that numerator stuff combined. I'm going to leave the denominator alone in factored form. My common denominator is this x plus, here, you can see it here, these 3 factors. So x plus 7 in any order, x minus 4, and x plus 3. So now that I have added these, I want to look at what would I never pick for my x. And I would never pick negative 7, 4, and negative 3. So my domain is going to leave out negative 7, 4, and negative 3. And the idea is, you know, we've been graphing with not quite like this. We didn't get into that much graphing detail. But you would know where your asymptotes would be and, for instance, where these things called holes are going to be. Okay? And that's it. I think that was it. Those are the notes for 7.4.